Hello, my name is Jonah Cesarivong. I'm a senior here at California State University of Sacramento, currently attending my last semester before graduating. I'm an aspiring athlete in a very niche field of endurance sports known as triathlon. I have dumped way too much money into board games, and I'm looking forward to investing my time into collaborating with people on personal projects, whether that vision be well defined or not after graduation. Today, I want to talk about a program called AlphaGo. But before I can do that, I have to talk about the game of Go. Go is a game that has been played for thousands of years and originated in the Chinese culture. It's two players sitting in front of each other, taking turns using their white or black stones, placing it on the board. And the goal of the game is to surround or capture the opponent's stones or strategically create spaces of territory that block them out from being able to place inside of those blocked out territories. Once all possible moves have been played, both the stones on the board and the empty points are tallied up, and the highest number wins. It is a relatively simple game, but it is very complex. As simple as it may sound, there are an astonishing 10 to the power of 170 possible board configurations. Just a little fun statistic, it's more than the number of atoms in the known universe. And this makes the game of Go a Google times more complex than chess. And that prefix is 10 to the power of 100, um, which is kind of fun to use. But yeah, interesting. You don't get to use that number a lot. So the artificial intelligence behind the program combines advanced search trees with deep neural networks. And the deep neural networks actually have subcomponents to them as well. These neural networks take a description of the board as an input and process it through a number of different network layers containing millions of neuron like connections. Um, and perhaps not necessarily millions, but you can see um, many different possible decisions that the program is calculating it can make in its given state of the board. And this black bold square that you see here is it's selecting a decision based off of the highest probability of success in the short and um, long run. One neural network is known as the policy network. It selects the next move to play, and the other neural network is known as the value network. It predicts the winner of the game. And both of these combined come up with a GPA of these possible decisions, which is just a grade point average, and chooses the best one. So AlphaGo was introduced to numerous amateur players at the beginning of its development, and that was to understand reasonable decisions that humans would make in a given game. And then it was played against itself thousands of times, each time learning from its mistakes. And that's one of the interesting things about the intelligence in this program is that, yes, it does require a huge amount of data in order to develop itself, but it's also immensely immersed into the self-learning aspect of artificial intelligence, where it can play against itself and come up with decisions that a human wouldn't normally make, or it basically makes its own decision. So I wanted to talk about a game called Frostpunk because I really like this game. I think it's a beautiful game, and I think it's very interesting. It's a real time strategy game, but it's nothing like StarCraft. It's not quite as intense, but I still really appreciate the lore and the concept in this game. And it's basically the end of the world has come. It's during the time of the Ice Age. A lot of people rally up and they travel together and they find a spot to settle down, which is basically the perfect habitat for building a large coal structure, which takes coal and it heats up the immediate vicinity. And when you're playing this game, you have to control and monitor your people on a day-to-day basis and send them to do jobs. But you're sort of working against time because every day it gets a little bit colder and it happens a little bit quicker. And so you need to work a little bit faster to develop a little bit more. so that way your technologies are more advanced and developed to heat up larger vicinities of this circle that you're kind of playing in. And these two little metrics at the bottom are discontent and hope. They're kind of a unique way of measuring your success in the game. If the discontent of the people that you're monitoring and controlling are high, then you're doing pretty bad. You're not fulfilling their needs and making them happy. And if the hope is very low, then you're doing bad. You need to create some hope inside of the environment so people have a will to live. And I think that's just really interesting. So on the second bulletin off here to the left, you have a list of priorities that these robots will execute, with zero being the highest. So if they're ever building a street and for whatever reason discontent's super high and people start protesting, well, people near those robots are going to start protesting. That's something that they're gonna prioritize over building that street. Um, yeah, there's plenty of different examples and how this works, but I really like. I think that's really interesting. Um, and so, one interesting fact about me is I didn't play Go. I didn't play chess. I actually didn't grow up playing strategy games in my household at all. I spent a lot of time outside doing activities because that's just what I wanted to do, and that's what my family and friends did. Um, but I later on started playing board games, and I fell in love with just playing board games, the social aspect of it, the artistic aspect of it, and also the world building. A lot of the times, the story and the rules. I have a deep appreciation for that type of that world building. Um, I think it's really interesting that you can kind of dive into a board game or a book and really just be kind of taken away by what it's like to be in that universe. I think it's really, really interesting. So that is me. I'm really excited to work with you guys throughout this semester, and I hope everybody's classes go as well as possible. So thank you very much.